Hey guys, my name is Jeff Stevens and I'm a game developer. I got my computer science degree from Denison University in 2021, and today I'm going to give you everything you need if you want to give yourself an honorary computer science degree. So I understand the winds have been changing lately on whether or not people want to pursue higher education. I get it. It's very unaffordable. There's a lot of bureaucracy. I'd like to share with you all of my textbooks, projects, and resources for my college classes so that you can see what a college class looks like and take it for yourself wherever you want as long as you have an internet connection. The textbooks for the first two classes are completely free, available online. The creators of the textbooks and the publishers have allowed them to be free. For the other books that are going to be used in this guide, you will have to either get from the library or purchase the books. That being said, there are some places where you can find book PDFs online posted for free. I'm not going to share those though, because legally that's not a thing that I want to get into, but there are some schools that share snippets of books and stuff like that that you can look up. So before we begin, lastly, I want to say that a YouTube video and this guide is not a direct substitute for a modern higher education. In a modern higher education, you will have resident professionals, professors who will give you one-on-one attention. Hopefully, if your education is set up in that way. You can't replicate that, at least doing a self-taught course in the capacity that I'm giving you right now. And you can't replicate having a cohort of students to network with and grow with and do work with. But still, I will give you absolutely everything that I did in college so you can do it on your own as well. Without further ado, let's begin. Alright, discovering computer science. This is the first class you take if you're a computer science major. You learn how to program, you learn what it's like to model mathematical and real-world problems on a computer, and the advantages of that. Pretty basic stuff. The really interesting part of this class was, although it's the first class computer science majors take, other majors take this class too to see if they like computer science. I sat next to music majors, creative writing majors, biology majors. Very interdisciplinary, very great intro course. You're going to learn a lot about yourself and computer science just by starting this one and seeing if it's right for you. The textbook is free. It's Discovering Computer Science by Justin Havel, a professor at Denison while I was there. Alright, second class in the major, Mathematical Foundations of Computer Science. At this point is where it starts to be pretty much all computer science majors, right? In this class, you're going to learn Boolean logic. You're going to learn what a Turing machine is. You're going to learn what a finite state machine is. You're going to learn all of the mathematical structures that underlie how computers work nowadays. And for some people, this is more pure math. This is more, we're doing everything on paper, very little programming at all. So for some people, this is less interesting, but yes, it's very necessary if you're going to understand the higher level concepts. The textbook that just came out by my old professor, Ashwin Lal, is free. It's the whole new content for the course. You can check that out. And then there's also the Book of Proof by Richard Hammack. That's out for free. And then there's one book for part of the course that you might use called Introduction to Formal Languages and Automata by Peter Linz. That is not free. You might be able to find a PDF, but I can't find one. All right, intermediate computer science. Now this is the weed out course. This is the class that decides the people who may or may not want to be a computer science major versus the people who are, they know they're going to do it. This is the class where you learn C++ and object-oriented programming. This is where things start to get more challenging from a newcomer perspective. Still, there's a lot of resources I have compiled here for you to figure out how everything works. As a programmer in my day-to-day life, I use C++ every day. I use object-oriented programming every day. The lessons you learn in this class when you take it are going to be, if you get into the programming career or a programming industry, you're going to use them every day. So very important class. Big recommend from me. Definitely do it. Data systems. Okay, so this is where you're going to use programming to interact with data, to process it and to analyze it. You're going to learn about databases and how to perform basic statistical analysis. One funny thing that we like to say, the alums, about this course is, and it's true, I've experienced it, if you work a corporate IT or software job, like 80% of the stuff you do in that job is just the data systems course. It's most work nowadays. SQL is ubiquitous. Databases are ubiquitous at corporate jobs. Doing data analysis, so making graphs for the guys in the sales departments. That's very important. And using APIs, that's a chunk of the work. Yeah. So anyways, if you want to know how to get a job in IT, or if you need to know what you need to do to work in IT or data analyst, you take data systems. Good course. Data structures. So this class teaches you, now that you know what object-oriented programming is, it teaches you the structures that you use within that object-oriented programming. What are their upsides? What are their downsides? What are the most optimal times to use a data structure for something? When should you not use a specific data structure to solve a problem? You'll learn this all in this course. In this course, you'll learn how to program a lot of the basic data structures from scratch, from the ground up, and you'll know how they work on the inside out, and you'll know the types of problems to solve with them, and that's going to give your code a huge speed boost and have an edge over anyone who does not understand how data structures work. So very much an important class to take, whether you're getting more into the theory side of computer science or if you're writing programs that need to be efficient and fast. Programming problems. So this was just a fun little 1-credit seminar that I took where we met one time a week to discuss little interesting programming problems. And these programming problems are from competitive programming contests. And once you learn about this, that's a whole other very interesting thing. What I've done for you here is I've cataloged the problems we did in the class. They're very cool problems, very interesting problems. And when you work on them, it's really going to improve your problem-solving powers. And I have to say from experience too, the problems are really fun because you get more credit if you write a program that does it faster than another program. It's competitive. It's pretty cool. So try it out. Introduction to computer systems. This is the hardware class. This is the class that we sort of introduce you to computer engineering. You're going to learn about wiring up circuitry. You're going to be learning from the smallest building block of computer engineering logic to using that to build your own CPU. It's pretty cool. The labs for this course, you're going to be working on labs from the textbook that are very challenging, very interesting. You're going to be learning assembly language code to interact with the computer at a very low level. Yeah, you're going to be getting a little kit here with electronics, working hands-on, building electronics, and getting creative. So very cool class if you always thought that aspect of computers was interesting. Natural computing. This is an elective I took when I was in the higher levels of my CS classes. And natural computing refers to algorithms that are inspired by nature. The genetic algorithm, the neural network. You can use these algorithms to solve pretty interesting problems, but in this class we specifically took these nature-inspired algorithms and we used them to solve optimization problems. The traveling salesman problem, the knapsack problem, all of that stuff which is very challenging problems to computers we can optimize and find pretty good answers to very quickly using nature's optimization algorithms. And you're going to be learning optimization algorithms, implementing them, and using them to solve real problems. So pretty cool stuff. Kind of niche, kind of a graduate research subject, but it's still very like an accessory piece of information that's kind of cool to know. So yeah, try it out. Software engineering. This is a class that I think a lot of people are going into computer science to become programmers and to get jobs that pay pretty well. Take software engineering. Please take it. What you're doing here for the software engineering course is you're effectively finding a client. You're going to get a team of other developers with you. You're going to develop software for this client and use specific methodologies that you learn out of the textbook to optimize your development process and to communicate with your client better and to deliver a product for them. So yeah, that's what we did for this course. My group and I, we worked for the local tourism department and we developed a kiosk for the tourism department. And yeah, it was a great experience. You get to actually network a little bit. You get to see what corporate needs are like and what working in the industry is actually like with an actual person who has a need. So great practice. It's good to have on your resume. I actually got my first job by showing them my project from this class. So yeah, developing that project portfolio, this is great for that. So definitely take software engineering if you are thinking about a career in programming. Fog, IoT, and cloud computing. This is another maybe more niche elective that I took in my higher level CS classes. In this class, you learn about how to interact with cloud services, and specifically the phenomenon of the Internet of Things, IoT, and how fog nodes are sort of like a lower level bit of cloud computing, and how all sort of encompassing that is in IT and in computers nowadays is the fact that if you are familiar, software as a service is now becoming a very dominant payment model for lots of different softwares and games. Learning about how that software as a service runs, the topic of cloud computing typically comes up. So understanding that and understanding networking, web development, how HTTP requests work, how to make a website, how devices on the internet can talk to your website and your servers, and how that corresponds with modern day cloud infrastructure. That is, you learn that in this course. You get a good introduction to that. So try it out if it sounds interesting to you. Algorithm design and analysis. This is the higher level theory course that you take in your computer science degree. You're going to be writing on paper. You're not going to be programming on a computer. You're going to be proving stuff about recurrences. You're going to be talking about why algorithms converge and making proofs using formal mathematical writing and putting it into LaTeX. This is something that some people who just want to go into programming might not find as interesting, but it's still pretty helpful to get a good foundation on how algorithms are designed, how specific algorithm design techniques allow for certain run times. This is it's not a favorite of some people, but it's a must take if you see yourself working in computer science academia, and helpful to take if you are trying to get better at writing out and understanding algorithms. Game design. So this was my favorite because I am a game developer now. But game design is a class that you take where you, very much like the software engineering course, you take, at least in my case, you took 10 weeks over the course of the semester. So most of the semester, you worked with your team in a group to design and program in a game engine your game. And what was really cool about this course at college was we worked with students in the English department or the creative writing department to write the story for our games. We worked with students in the music department to write music for our games, and we all came together at the end of the semester for a sort of a interdepartmental showcase of everyone's work all sort of coming together. And that was really cool. I remember seeing that on the brochure when I was a senior in high school, and I knew I want to go here. And it was cool to experience it, but it's a lot of work. And I was barely limping over the finish line when we were doing this. It was it's crazy. If you are interested in game development, this absolute must take. If you're not, this is not a must take. This is something that is kind of a fun, but it's also practice at software engineering because you are, again, working with a team to deliver a product and accepting feedback from people at demo sessions, writing that into your backlog to add stuff, add features to your game so that it can meet the expectations of your players. It's a great class to take, very fun if you want to be a game developer, very necessary. If you don't want to be a game developer, it's just good software engineering practice. You might just want to take more software engineering instead, but still, I had a lot of fun with this one. Yeah. All right, last but not least, we have AI. This is a big one. So I should say before anything else that the AI that people are really excited about nowadays is called generative AI. The large language models like ChatGPT and DeepSeek are generative AI. The AI that we learned in this course was right before the big explosion and growth of AI, and we studied mainly machine learning algorithms. But you're going to be using AI methods to identify flowers from a flower data set, classifying pictures of dogs versus cats with a neural network, right? The idea that you learn from this course is that AI is all very good statistical predictor models. Once you learn how the most basic of the statistical predictive models worked, then you learn about how the really complicated ones will start to work. So interesting course to take, definitely recommended for pretty much everyone nowadays, even though it was originally an elective. AI is getting out of control, so recommend for me on understanding how it works. Okay, that's my entire CS degree. There it is right there. That's the kind of stuff that they're teaching in college. All of the assignments, all of the textbooks. Get a textbook, Start reading the first 2 ones that are free. Start doing the assignments. This is what people are paying money for in college nowadays to learn. So yeah, it's all there for you right there. My mission is information transparency. This is going to be a living document too. It's going to be in the description, but I'm going to be updating it based off of feedback and based off of maybe little things that I remember over time or documents that I recover, or if I get permission from professors to put more of their things in here. We'll figure out that. But anyways, thanks for watching. Really appreciate it. This has been a big project for me, so glad to finally share it. Have a good one. We'll see you.